And I'm Ouyangと申します。The topic is developing a Japanese English literary parallel corpus from Aozora Bunko and Project Gutenberg. And the presentation is divided into 6 parts. And the first part is background. In literary machine translation domain, compared to general machine translation tasks, literary translation presents unique challenges. It demands addressing complex discourse level phenomena, for example, pronoun resolution and intersentential consistency and topic coherence. And therefore, some research turn to context-aware and document-level translation approaches, which incorporate broader contextual information into the translation process. And it also highlighted that literary machine translation as an ideal test bed for advancing context-aware machine translation, because the literary texts have rich discourse-level phenomena. Additionally, Lim noted that poor performance of current context-aware MT models is not related to the capability of model, but from the sparsity of discourse-level phenomena in the existing data sets. And this underscores the critical need for the data sets that include such complex linguistic features. And however, the resources for the Japanese and English language pair literary translation still remain scarce. And the only related existing data set, the English-Japanese translation alignment data, and which is developed 10 years ago. And so the purpose of this research is first, aims to resolve the limitations in sentence level aligned corpora. And second, aims to build an open literary domain parallel data set. Recent years, researchers had developed many literary parallel corpus, and just as listed above, the only existing multilingual data set is developed 3 years ago, and the portion of Japanese English is very small, while the others are in Chinese and English language pair. The available source for Japanese and English remain limited. And then I will introduce the proposal. The bilingual text mailing comes from the Aozora Bunko and Project Gutenberg, and the construction pipeline can be divided into document alignment, paragraph alignment, and sentence alignment phase. And before alignment, there are some text pre-processing and cleaning procedure. We mainly clean the header description, symbol explanations, and phonetic annotations. And below are some examples in the practical. And for English works, we removed all the illustration text and annotation information, which are frequently exist in the Project Gutenberg text. And additionally, other types of pre-processing had been also done. And then the document alignment phase. We have defined an agent system in which the user agent and the AoGu agent, these two agents are implemented using the Python scripts, while the assistant agent is composed of GPT-4o and Cloud 3.5. The system message for the assistant agent is structured as follows. We define the assistant agent as a scholar of world literature whose primary task is to return the corresponding English name when provided with the author and title information from each Japanese document. And for example, in this case, if we provide Westminster, Jin, and Washington Bingo, we expect the assist agent to return the appropriate English names. And the overall system workflow is as follows. Send initial request from the user agent with extracted order and title information, and then perform character level matching from the Project Gutenberg metadata. And the response is checked against the metadata from the Project Gutenberg. And if a match is found, the document is added to the R. And if no match is found or the response is no match, which is listed in this system message, the AoGu agent extracts additional Japanese text from the document and submits an extra request. And this This retry process is attempted up to 3 times per document, and finally, the aligned document is returned. After obtaining the parallel documents, we perform the paragraph and sentence alignment. For the paragraph alignment, we first extracted paragraphs from the English documents using the labeled information. The final parallel paragraph consists of original documents of the Japanese works and corresponding chapters from the English documents. And for sentence alignment, we first fine-tune the sentence segmentator using the Utsuro data to adapt to the literate text, and then using the vector line for sentence alignment. The Labus and Laser 2 model were utilized for embedding. And below are some hyperparameter for the segmentation and alignment. Next part is the statistic and the baseline experiment. The statistics are counted from the 530 documents out of 634 documents. To compute the number of subwords, the tokenizer from Labus was utilized. At the sentence level, the statistical information shows that the total number of the sentence pairs is more than 3 times of that of Utsuro data, list the third line. We train a 6-layer transformer model with 8 multi-heads and 512 embedding dimensions. At the same time, we set up 4 experimental groups where the Labus and the laser 2 represent the embedding model used in the sentence alignment stage, and the number 0.4 and 0.6 refers to the similarity sampling threshold, and the blue score for all of these 4 experimental groups are relatively low, while the common score are relatively higher, indicating that the models trained at the sentence level exhibit limited performance. We also conducted tests on the out-of-domain aspect dataset. The blue scores for all 4 experimental groups were extremely very low, and indicating that the significant textual difference between the literary and non-literary corpora, as well as the limited generalization ability of the model. And next part is the translation case analysis. There are 4 translation cases, and for the case 1, the source sentence reflects the speaker's perspective. For example, the bride is speaking, whereas the reference adopts the listener's perspective. People is listening. Grade was followed with rapt attention. The model maintained the source perspective. Grade was talking wildly. And additionally, they can be ambiguous, describing either the speaker state chosen by the model or the listener state chosen by the reference. And in case 2, the source text used tegami as the pronoun, but the reference preserved the letter in the same row. However, the reference preserved the letter in the same row. However, the model replaced it with he, and altering the original perspective. This demonstrates the model's insufficient understanding of the contextual coherence. And for case 3, the model failed to handle the pronoun correctly, and compared to the model's direct translation, put his foot to my house twice. The reference translation leans more toward a free translation. You would never have put another foot. And additionally, the reference tends to use the free translation rather than direct translation. So it's a much konasta. You may lay to that. And for case 4, the reference translation sentence structures are more diverse, reflecting the characteristic of literate text, whereas the model's translation tends to adhere closely to the sentence structure of the source text. And here comes into the conclusion. This research developed a Japanese English literary parallel dataset, and mainly using the bilingual data test from Aozora Bunko and Project Gutenberg. And second, the baseline settings trained under the sentence level. Parallel data show limited performance in blue and common score. And third, literate text shows its characteristic diversity and impose higher demands on translation model in terms of this discourse level phenomena. And for future works, currently we also face some problem. In literary translation, to ensure the readability and the fluency of the translated text, human translation experts often translate the source text according to different linguistic conventions and regional styles. And as a result, translation may not strictly adhere to sentence alignment, and some misalignment types are listed in the figure 1 above. And these are listed in three types: insert, delete, and slip. These are not strictly adhere to sentence alignment, and this impose a challenge to the in sentence alignment heritage. And also, free translation and faithful translation frequently alternate in the AoGu dataset, presenting a challenge for sentence level alignment. For example, the free translation, if significant difference in expression between the source and target will pose a challenge for the modeling capability of the embedding model. And this model, which is trained on the strictly parallel data. And also, insert and delete types will pose a challenge to the sentence alignment paradigm. And future works will focus on three aspects. The first is refine the dataset by explore adequate alignment method to add context. And this context will be used for handling the complex semantic relationship, which a sentence level model cannot be easy to handle. And second, explore the paragraph and document level training and inference settings to enhance the performance of literary translation. And third, explore LLM-based training and inference settings on literary translation tasks. And that's all. Thank you. Thank you so much for listening.
Okay, thank you very much for the presentation. 質問があったら Q&A の方に書いていただければと思います。So, could you go back to the 質問が今ちょうど来ましたので、so thank you for your presentation. Could you briefly explain why this assistant agent model is used to provide English translations of corresponding works, and why this mode is adopted to retrieve document pairs?
Hi. Because in our preliminary experiments, we found that most of texts in Aozora Bunko are just a part of larger work, and some Japanese texts only correspond to a very small part of the corresponding English text. And the effect of using the traditional embedding similarity-based method is not as good as using the name index method. And since the Aozora Bunko and the Project Gutenberg are widely used pre-training resources, and the existing large language models, for example, the GPT-4 and Claude 3.5, have already trained with this relevant knowledge with this literature. So that's why this method performs. Hi.
Okay. Yeah, I also have the very similar questions. Why you need this kind of complex model is needed to find paragraph alignment. So this is because the whole literature is not translated into the other language.
Hi.
Okay.
Because in general case, in Aozora Bunko, many works in Aozora Bunko is just a very small part of that in the Project Gutenberg. So we chose to use the embedding-based method to retrieve the parallel documents. Maybe the effects is not as good as we design.
Okay, I understand. Okay, so it's almost up time. So thank you very much for the presentation.
Hi, thank you so much.
Thank you.